Second example is going to be a long one. It's going to create a bunch of different ideas that are all going to hook together and help us understand how this stuff works. So if we have a ball being thrown out of a window from a height of 10 meters with an initial speed of 20 meters per second, angle of 30 degrees above the horizontal, we can ask some questions. What's the initial velocity vector v for the ball? Then, ignoring air resistance, how long does it take for the ball to hit the ground? And C, finally, ignoring air resistance once again, what's the ball's displacement from its starting point and what's its distance? Okay, so we've got some building, right? And here's the building, and it's got some window, and somebody throws a ball out of that window. And we know if we were to set a horizontal straight line, this is going to be an angle of 30 degrees, and this ball comes out at 20 meters per second. So down here is the ground, and as time goes on, the ball is going to fly forward, and then gravity is going to take more and more of a share of its velocity, and it's going to eventually land and hit the ground somewhere. So what we want to do is we want to figure out how long is it going to be flying through the air? How long is it going to take before its y location, its y-axis location, hits a 0? Once we know that, we can figure out how far it's going to make it to the right. But first we're going to have to know what's its initial velocity vector. So if we've got something that's 20 long on this side, and we know it's 30 degrees here, we can figure out what the other sides have to be just through trig. So this side, since it's the side opposite, is going to be sine 30 times 20. This one will be cosine 30 times 20. So cosine 30 times 20, that gives us root 3 over 2 times 10, which comes out to be approximately 17.3 meters per second. And sine is going to be 10 meters per second. So that's going to give us an initial velocity vector of 17.3 to the right, comma, 10 up meters per second. Great. Now we're ready to move on because now we've got a vector and we can use those vectors and break each component off and work with each component separately. If we want to figure out how long it's going to take that ball to hit the ground, we don't care what its x component is, right? It's the same thing if the ball hits the ground here, hits the ground here, hits the ground here. All that matters is when does it have that 0? When does the ball make contact with the ground? When is the y-axis location 0? So if we've got distance as a matter of time is equal to 1/2 acceleration times time squared plus velocity initial times time plus the initial location, well, we can then just break this into looking at the y's throughout. So we just look at the y components throughout, and we can figure out when is it going to hit the ground. So what is its acceleration? The acceleration is negative 9.8. So 1/2 times negative 9.8 times time squared. Plus, what's its initial velocity? Its initial velocity is it's moving up at 10 meters per second times time, plus what's its initial location? It starts at 10 meters above the ground. So we want to solve this for when does its location become 0. So we want to make that left side, we'll set it equal to 0, and then we want to see what time will allow that 0 to appear on the left side. So negative 4.9 times squared plus 10t plus 10. So how do we solve something like this? Well, we've got a couple choices. Right here, we've got a polynomial, right? If we've got a polynomial, one of the first things we can do is factor it. But to me, that doesn't look really easy to factor it. So the easiest thing after that is to just chuck it into the quadratic formula, make that machine go through it, and it'll grind out an answer for us. What's the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's going to be the solutions for when time is going to make it equal to 0. So that gives us one way to do it. One other way, if you've got access to a powerful calculator or a numerical solver of some sort on a computer, you could just plug that into it and tell it to solve it. But let's go through the quadratic formula because we can all just work through it that way. So the answer to this is going to be time equals what's b? B is this one right here. So we've got negative 10 plus or minus square root 10 squared minus 4ac, what's a? Negative 4.9, so 4 times negative 4.9, have to include that negative, times c, c is right here, 10. All divided by 2a, so 2 times negative 4.9. Keep working through that. We get negative 10 plus or minus the square root of 100 plus 196, because we're going to get cancellation in those negative signs, divided by negative 9.8 equals negative 10 plus or minus square root 296, all divided by negative 9.8, which is going to be equal to approximately negative 10 plus or minus 17.2 all over negative 9.8. So now we're going to have to ask ourselves, are we going to go with the plus or are we going to go with the minus? Because mathematically, both of those are correct answers, right? Both of those are times when this equation right here is going to be fulfilled. It will be fulfilled. That equation will be fulfilled both at the plus and the minus, both when we use this and when we use this. But we can see logically that the ball only hits the ground on one side. It doesn't have both a forward time and a negative time. So what we want to do is we know our answer can only be a positive time because this equation isn't true at t is less than 0. Before this moment, we don't know where the ball was. The ball was sitting in some apartment before somebody picked it up and decided to throw it out the window. So at that moment, that equation right here wasn't true before time equals 0. Once time equals 0, that's the moment of the ball is actually thrown. We know we can start using this equation. So we can only find, the only solution that will work is the one where time is greater than 0. So we look at this, and we're going to have to find a way for us to have a negative number on top, because negative 10 plus 17.2 would give us a positive on top, then we divide by negative, we wind up getting a negative thing. So we're going to actually have to go with the negative answer right here, the one, not the negative answer, but the negative of the plus minus, because it's the only one that would work. If we were to solve it out and get both answers, we'd be able to get two of them. One where we've got a positive answer and one where we've got a negative answer. But the negative answer we know can't work, so we have to choose which sign is going to give us a time that's positive. We chose the negative one, so we can knock out this positive one, and we're going to get 2.78 seconds. So that ball has 2.78 seconds of flight time before it hits the ground.